Okay, so this is our first look at an entire problem. What this problem will entail is us doing rational roots theorem to get our possible roots. Then we have to do factor theorem until we find our first root. Once we get our first root, we're going to plug it into synthetic division for us to find our depressed polynomial. Then we're going to factor, then we're going to sketch. So this is a progression of all the skills that you've been taught so far. Let's get started. The first thing we need to do is check for P and Q. So this is the rational roots theorem. P comes from our constant, which is 10. So P has factors of 1, 2, 5, and 10. Q is our coefficient of the x to the third term in this case. So our Q is plus or minus 1 and plus or minus 2 because those are the factors of 2. Now what we're going to do is we're going to do rational roots theorem by taking our ratio of P over Q and writing all of the possibilities down. So the first thing we're going to do is we're going to take all of these and divide by 1. And when we do that, we're going to get all of these again. So when we take our plus or minus 1 and plus or minus 2, plus or minus 5, and plus or minus 10 and divide by 1, we're going to get the same thing back. Then we're going to take all of these p's and divide by 2. And what that will do is give us our other set of combinations. So plus or minus 1 over 2. Plus or minus 2 over 2, well, that's really 1, and we already have that, so we don't have to repeat that. We have plus or minus 5 over 2. And plus or minus 10 over 2, well, 10 over 2 is 5, and we already have that 1, so that's it. So these are all of the possible roots that we could have for our polynomial. And somewhere in here is going to be our winner for our factor theorem. So we just did this. Now we have to find one of them that works. So this is where we're going to start with positive 1. And we're going to plug positive 1 in and see what happens. So I'm going to take 2 times 1 to the third plus 7 times 1 squared minus 17 times 1 minus 10. And I'm going to calculate that. So that's 2 plus 7, that's 9. Minus 17 is negative 8. Minus 10 is negative 18. So this is no. This is not a solution. We got to try again. So now I'm going to try negative 1. I only have to find one of them that works. So I'm going to plug negative 1 in. And so I have to make sure that I'm squaring or I'm cubing before I multiply by 2. So this is going to be negative 1 times 2, which is negative 2. This is negative 1 squared is positive 1 times 7 is just regular 7. So I'm at 5. Then I have negative 17 times negative 1, which is positive 17, which is 22, minus 10, which is 12. So that's a no. All right, so 1 and negative 1 don't work. We're going to go ahead and now we have to try 2. We have to find one of them that works. Once we get 1, we're good to go. So we're going to plug 2 in. Hopefully 2 works. That would be amazing. But this is indeed how you do the entire problem. So this is 2 to the third, which is 8, and 8 times 2 is 16. This is 2 squared, which is 4, and 4 times 7 is 28. Then I have negative 17 times 2 is negative 34. And then I have minus 10. And I get 0. Boom. This is our solution. This is fabulous. So I can stop doing my factor theorem now. I have an answer. Once you have one, you can stop. So what I have to do now is I have to take my 2, my winner, the one that's the solution, and I need to do synthetic division. I need to figure out what the rest of the polynomial is going to be. That depressed polynomial, I got to figure out what it is. So I'm going to take my 2, that is a solution, and I'm going to divide it into my polynomial using synthetic division. I do have all of my terms, so I'm just writing my coefficients down. And I am doing synthetic division because I know I'm going to get a remainder 0. I already know it's a solution. I just need the stuff before that. I need the depressed polynomial. So I'm going to bring my 2 down. 2 times 2 is 4. I'm going to add it. That gives me 11. 11 times 2 is 22. I'm going to add it. And that gives me a positive 5. 5 times 2 is 10. I'm going to add it. And my expectation is to get 0 because that is the remainder. These two have to match at the end. Okay? So now that I know that it's a remainder, I know that this is a factor, and we are going to write our depressed polynomial. That's this guy. So our depressed polynomial is 2x squared plus 11x plus 5. This is called a depressed polynomial because it's 1 degree less than what our original polynomial is. And you get those depressed polynomials by having a remainder of 0. Once you get this, what we need to do is factor this. And you can either factor it, you can complete the square, you can quadratic formula this. Whatever way you can get to get the rest of the solutions, you can go ahead and do. But this is a quadratic, which means that for me, it's easiest to do that magic X method that Miss Meek showed us. A times C, which is 2 times 5, that's 10. Our middle term we're adding to is 11. That means I need a 10 and a 1. Don't forget I have a coefficient of 2 here, so I have to divide by 2, and I'm going to get x plus 5, that's what 10 over 2 is, and x plus a half. Now what this means is that I'm going to get 2 extra solutions. So I'm going to set this equal to 0, and I'm going to solve each of these. Well, if x plus 5 is 0, I know that my solution is going to be negative 5. So that's another solution. Boom. Then I know that if x plus a half is equal to 0, then my solution is going to be negative a half. Boom. So just check and make sure that these are all on our potential list. So is negative 5 up there? Yep. Is negative a half up there? Yep. And we know 2's up there because we already checked it. And these are our 3 solutions. And I know I only have 3 because my highest degree is 3. We are actually almost there. So we have, recap, we have done our rational roots theorem. We found a root that works. We use that root, that solution, into our synthetic division to find our depressed polynomial. Then we factored this polynomial to give us our other answers. Now it's time for us to do our sketch. What do we need for a sketch? Well, what degree is it? It's a degree 3. That means it's a cubic. My A value is positive, which means that my end behavior is going to end up. I also know that my y-intercept is my 0, my constant, and my constant was negative 10. And I already have my solutions, guys. My solutions are already there. I've got x-intercepts are negative 5, 0, negative a half 0, and 2, 0. Let's sketch. So my y-intercept's at negative 10. I have a negative 5. Here's, I'll call this negative a half. And here's 2. And I know it's going to start down and it's going to end up because it's positive. So I'm going to start down over here. I got to come up on the 5. I got to come down on the -0.5. I got to cross at -10. And I got to come up at the 2. There's my sketch. This is one problem completely done.